So let me introduce our first speaker, Robin. He works as a technical architect at IoT5. He has a proven record in software architecture and technical ownership. He brings a unique blend of hands-on knowledge, diverse skill set, and a passion for curating cutting-edge technologies. He's a regular speaker in meetups. So let me hand over the stage to Robin and take it forward. Thanks.
Thank you, Humble, for that great introduction. Just if you'll allow me a few seconds to set up this for presentation. So this is my first virtual, the first virtual talk that I'm giving. Mostly it has been in person, so I'm just trying a few new things here. So if something breaks, it's very much in alignment with the theme of my talk, basically tinkering and playing around with things, which is what HomeLab is about, right? So let's see how this works together. I hope my screen is visible now.
Yeah.
And my camera as well?
Yeah.
Okay, thank you for confirming. Okay. Okay, so this is going to be a 30 oops. Okay, we are starting off with a few glitches. But okay, so this is going to be a very quick 30-minute talk. So the scope of what we are able to cover might seem a bit limited, but the overall idea is to get people excited about HomeLabs, get people to try out certain new technologies. And I think most of the people who have joined here, especially on a Saturday morning, are people who like to tinker around with things or like have that passion for learning. So I think that would be quite well suited for you as well. So as the title suggests, the goal is Kubernetes in a home lab. Now, we have a lot of Kubernetes experts here, as well as there are a lot of, as somebody flagged, there are a lot of resources available for getting started with Kubernetes. But quite the contrary in the case of a home lab. And the resources are a bit lesser. So the focus of today's talk is going to be a bit more on the home lab side, and we are just going to show just the basics of Kubernetes, as in how to deploy something in Kubernetes and how to expose it publicly. That's going to be the bare minimum. And that's the objective of this. So this is for absolute beginners, and this is just for your home environment. This is for that old laptop that you saved, you do not know what to do with, or some old computer that you want to repurpose to do something cool with it. That's it. That is the intention of today's talk. So now that we have the background set, let me just give a very quick introduction about myself and my background as well. My name is Robin. You can find me in most places with my website, thomasrob.in. I'm natively from Cochin, Kerala. Did most of my schooling there. And I've been working with IoTify.io, which is an IoT testing tool. And it's a startup based in Switzerland. So being a startup, you kind of have to wear a lot of hats. So I do most of the things from architecture to design, development, and etc. So that's why I'm a bit of a generalist, and I like exploring new technology, keeping myself updated with a lot of new cool stuff, especially when it's open source software. I had a stream on YouTube based on open source software called Jumpstarts, but that's back in 2020. Maybe we'll try to get that going again. So basically like a polyglot, trying to cover a lot of space within the open source as well as software ecosystem. I think with that we can kind of get started with what a home lab is. So home lab, what is it? Now I'm sure everybody is quite familiar with Mr. Bean, right? So it is just a safe space for you to tinker, to play around with cool things. Say you came across a workshop about WebAssembly, or you came across a workshop about some new Docker image or some new project that you want to give it a try. We usually have one laptop for our work, or one laptop for our personal computing. It is very difficult if that goes offline. If there are people who are dual booting, they can personally attest to how many times it has broken and then caused significant disruptions to their workflow. Just a quick interruption from the talk here. There's also an option to raise your hand, or to I'm also monitoring the chat. So if you have any questions, like to keep it as interactive as possible, please feel free to either raise your hand or fire a message in the chat, so we can quickly address within the context of the talk itself. So like I mentioned, dual booting is a very difficult and a very adventurous approach, I would say. So HomeLab is its essence is just to repurpose some old hardware now, and give you a place to tinker, prototype, try new things. That's essentially the intention of a HomeLab. Now I can just to really drive home that point. This is how my HomeLab started. What you see here is my mom's old laptop, which is an i3. It's a Vio, and in case you want to, in case you're questioning how old that is, Vio is no longer like selling in India itself. So, just a second. I think is my screen visible?
Yes, how it started.
Okay. So yeah, so this is just an i3 laptop which had a battery issue as well as RAM issues, and storage was broken and everything. Basically, the only thing that was left to do is throw it in the garbage. And what you can see here is I basically took that, added a very old SSD that was also ending its life, like near towards the end of its life, and essentially loaded this Proxmox environment. We'll cover what Proxmox is. We have a few interesting questions that might come up about VMware as well. You can actually see the VMware ESXi running inside Proxmox. There can be a lot of interesting concepts. So you can pretty much try anything in this environment. It's supposed to be a safe space where you can experiment. Hence the lab part of HomeLab. It's like having a laboratory. How it's going. So once you kind of get started with this, I think even in the description or even in my LinkedIn post, the way that I put it is you basically need almost nothing to get started with a HomeLab, but it can be a rapidly escalating addiction. So back in 2020, I built this system. So in addition to my laptop, this was basically like my personal testbed / home server, right? So this is a Ryzen 3600. The GPU does not really matter much in these cases. So this is like a GT 710, which was the cheapest GPU that I could buy. GPU is not as much of a factor in most HomeLab cases unless you are planning to do some ML training. I'm not. That's one field that I do not actively engage in. It started off with 8 GB of RAM, but there were 4 slots. So eventually I populated 2 slots and then 4 slots, and now it's all the way up to 32 GB of RAM and approximately 5 terabytes of storage, out of which you'll see NVMe drive over here, primarily for virtual machines where you need fast storage. This is a scrapped old SSD, which you might recognize over here. It's a 40 GB SSD. You can use a pen drive as well. SSD is a bit more reliable. This is also another 240 GB SSD, again for fast backups, like caching backups. And over in one of these bays, there is a 2 terabyte hard drive, and there's also an external 2 terabyte hard drive. So comes approximately around 5 TB. So what is it? So I consider it as my personal test bed. In general, the popular sentiment around HomeLabs is it is a personal test bed that you can tinker on. It's a platform where you can self-host your websites on. If you go to thomasrob.in, this is actually being served from my flat. So to Jojin, who asked the question about HomeLab's uptime. If you go to my website, you will actually see an uptime graph, and it's actually pretty high. In case I also have a fallback mechanism set up so that in case my Airtel connection or the power goes off for an extended period of time, it will the traffic will get rerouted to another cloud instance. But almost always when you visit thomasrob.in, you're actually going to land on a website that is served from my flat in Bangalore. Learning tool, as I mentioned, if you come across a workshop or if you come across a particular Docker image or something that you want to try, this is the best way, learning by doing. So always you can either watch endless YouTube videos or like read a lot, but the amount of learning that comes by just doing it, or at least at a minimum capacity, that is quite significantly greater than anything you can hope to grasp by reading or by listening to other people. So just even if you have a limited capacity of just trying something or trying to deploy a minimalistic image of what you're trying to accomplish, that is the best way to learn things. Project-based learning or application-oriented learning. And this is the best toy that I own. I thoroughly enjoy deploying new things on it, extending its potential, pretty much surprising myself with a lot of the new things that you can do, and definitely presenting it and sharing some of the things that I have been able to accomplish with this. So a few best practices, since this is a getting started video. Just a second, there seems to be okay. So a few best practices, since we are just getting started, and this is an intro. By all means, you can start off the quick and dirty way. You can start off with Ubuntu. Literally, there are endless number of ways. Since there is no defined way of going about an experiment of this in this space, you can sort of start off with however you want. You can start off just by flashing an Ubuntu instance. You can just start off by using Proxmox, anything. You can start off on Windows itself. I would highly advise against that. But these are just a few best practices that that I recommend. So apart from your internet service provider's router, which is usually like your OST, that white box that they come and install, it is good to have a separate router. You can get a cheap one as well. The first one that I started off with was for my Raspberry Pi cluster. It was a 500 rupee router. Basically, you need something that can handle DHCP, something that you can use to assign static IPs, because as in the case of any experiment, you need to limit the number of variables that can happen, right? So in case your DHCP lease, as in when your device connects to a network and it has DHCP going on, an IP address gets assigned to it, and this is assigned for a specific duration. So when you're debugging something and suddenly something doesn't connect because or some IP address changes, you'll start pulling your hair out. So that's something you want to avoid. Static IPs are quite good. The advantage of using a virtualization layer, a hypervisor, is that you run everything as virtual machines. And Humble pretty much wrote the book on KVM virtualization. So I think it's worth highlighting the impact and the necessity, or rather the benefits of virtualization in this context as well. So you can do snapshots. So in case you screw up, you can always revert to a previous image before you tried something. And the last one is something that I am trying to get better at, is documenting what I do. There have been phases where I have deployed something quite successfully, is running quite well, and then suddenly something happens. I have to redeploy it, and then I have to go searching through my bash history to see what commands I actually did. Because you can follow tutorials all you want online, but certain things would be specific to your particular environment, right? As somebody asked earlier, when you get started, there are paths that you can follow, but as you kind of go deeper and deeper, your environment becomes more specific to you, and those preset commands and troubleshooting steps might not apply to you. So you kind of need to remember, do not always trust your memory. Have at least like a markdown file or a text file. Maybe even have a GitHub repository on saving notes. It's a very good practice. So I think I will pause on the presentation there and move forward to just giving you a walkthrough of what I have going on. Just some context before we go through the walkthrough. The approach that I have taken is, on top of my bare metal, I have a hypervisor, and on the hypervisor, I run virtual machines and containers, and Kubernetes goes within these virtual machines. Hypervisors itself are of two types: type 1 hypervisors and type 2 hypervisors. Type 2, just a very brief overview of what these are. Type 2 hypervisors are VirtualBox, VMware Workstation, all of these which you install within Windows or Linux or whatever, that you can use to basically play around with operations or certain experiments. Those tend to have a bit more overhead. Type 1 hypervisors are much lower. You can basically flash it directly into the operating system. Those come with the hardware drivers, etc., and you can essentially, examples of this is VMware, ESXi, Proxmox, as I'm planning to show today, Citrix, Zen Server, etc. I think that should cover the presentation itself, and let's just dive into our walkthrough now. 1 second. Just okay. So this is the most common interface that you come across with Proxmox. So Proxmox itself is a Debian distribution. The version that I'm running is 7.x. So you can from scratch sort of deploy Debian and then install the Proxmox packages and repositories on top of that, or you can just download their own installer, and that's basically what you saw in the screenshot that happened earlier. Similar to VMware ESXi, you have a data center level deployment that you can do, and you can also have specific nodes. So what do we mean by data centers? What do we mean by nodes? Just to give you a brief overview there. Here we are basically dealing with a single node. As in, I only have one machine, so that's going to be my one node. If you want to deal with high availability, or if you want to deal with certain other use cases that are similar to enterprises, it's good to have three. So if you want to run three machines, by all means, you can try that as well. You can also install Kubernetes natively instead of this Proxmox layer. You can just flash a minimal Linux instance and then install your Kubernetes distribution. But since it's a HomeLab and I host other services along with Kubernetes, this is the approach that I've taken. So in terms of design decisions, there is no real correct answer to anything that's going on. It depends on your priorities. If you are like into hardcore Kubernetes and you just want plain Kubernetes, in fact, when I actually say the Kubernetes flavor that I'm using, there can be quite debates about that itself. So again, I'm just going to give you a walkthrough of what exactly is being hosted here. So OMV is Open Media Vault. Open Media Vault is a very good storage solution. So like I mentioned, there are 2 into 2 terabyte hard disks that I handle here. So it is actually quite good to not have that within your. So Proxmox, a lot of people use it for ZFS as well. I am using just standard NTFS and FAT for this, because ZFS comes more in use when it's using clustering workloads. So if I just quickly show you here, there are those hard disks itself can be passed through to this virtual machine. And within the virtual machine, you can, oops, I got logged out. Within the virtual machine itself, you can actually see those disks. You can assign. The advantage of this is instead of having your storage managed in multiple different places, you can very easily have all of your network shares, etc., managed here. So my computers themselves do not have a lot of storage. All of the storage, all of the synchronization, everything is handled over here. So NFS shares, for example, here the server itself is called Appledore. So all of those storages can be centralized. This is called a network attached storage, NAS. So within your Windows file system itself, you can expose something called SMB. So if you want to say share something with your TV, you can connect to this over the network. All of that is quite possible. So that in a sense is Open Media Vault. Even if you have virtual machines, you can mount NFS shares. So these folders that you're sharing, you can mount them into your virtual machines and then operate on that. While we are here, we can also, so Hudson is basically what runs most of my Docker containers. WireGuard is like a peer-to-peer VPN solution. So even if I'm outside the house, similar to how most people tunnel into their, have to VPN into their company network, I have the capability of VPNing into my flat. Pi-hole is your DNS, is my DNS server over here, for example. So here, if you see dns.local.thomasrob.in, when you get started, it's very easy to just host services and then you can use your IP address. For example, this is using proxmox.local.thomasrob.in. I remember that my IP address for that is 100 and then this. So this is the easy way to do it, but you will come across this not secure HTTPS warning, which you have to, because the certificates will not be valid. What you can do instead of that is sort of have a DNS server, and then you can have a network level proxy to handle your SSL as well. So that's how I have this dns.local.thomasrob.in going. If you try and try to access this outside my network, it will not happen because none of this is actually exposed to the internet. This is all within my network. So yeah, some of these services I have not proxied because I do not actively need to use these pages. But DNS, for example, here you can do ad block here. Pi-hole is one of the most popular examples. It was actually created to run on a Raspberry Pi. Raspberry Pi is one of the most popular HomeLab solutions for people to get started. It's a very affordable way for people to just try out a couple of services. Most of the Docker images are available in ARM as well, so you can quite easily deploy stuff on Docker. So yeah, I think so. Here you will see the DNS requests that are coming up. So this will essentially handle your DNS lookups. So you just need to go into your router's configuration and then use this as the DNS resolver. Again, a bit out of scope to explain what DNS is. If we have time, we can answer that during Q&A. So that's Pi-hole. Home Assistant is an IoT IoT server. So similar to how your Tuya, your Wipro, Cisca, all of those bulbs essentially is a white labeled solution called Tuya. So you can sort of self-host your own server and then connect all of those devices to your Home Assistant solution, and then you can run it from anywhere. In fact, I have like a control panel here, which actually allows me to toggle some stuff, the lights and stuff that I think it's a bit out of frame. The lights, etc., of my room, you can sort of control it through my home server itself. DevVM, this basically just contains like Node.js and Golang, which is the languages that I know or you use. So if I want to try a programming project, rather than doing it on my laptop, I can just very easily you do it on this virtual machine. Humble, how are we doing on time?
I think we have 5 more minutes.
Okay. So wrapping it up really quick, I think moving on to the Kubernetes side. Web server, this is where thomasrob.in comes in. This is actually, like I mentioned, being hosted here. You can check this out later. Let's just see the availability graph. Of course, the demo FX strikes. I think that particular service is down. But yeah, let's just quickly go over to the Kubernetes side of things. Now, there is a solution called Portainer. which actually uses which is actually more popular among Docker. Now, a lot of in this journey, like I mentioned, HomeLab is a very quite evolving journey, right? So initially, I started off with K3s, or rather, initially I started with the vanilla Kubernetes, wherein you have to basically deploy everything from your CNI onwards and manage that, which was not the most stable way of doing things. Then I switched to K3s, and then one fine day, managing that along with the job when I wanted to just try and deploying some stuff was getting a bit difficult. So I went to Portainer with Docker Compose. So that's mostly what you see in this local. So these are basically stacks of all of the services that I showed you. This is very similar to a Docker Compose file. What I am doing right now is migrating everything to micro K8s. So what you can do is either link Portainer to micro K8s. It just gives you a very pretty interface. It's just a GUI for Kubernetes. You can even have Kubernetes dashboard, which micro K8s also very easily gives you Kubernetes dashboard. So I think in the interest of time, I'll just show you a couple of Nginx deployments, I guess, that have been given here. 1 second. So similar to how you essentially give your deployment YAML. So this is just the direct example of, since we are a bit short of time, I was planning to show this as a live demo, but similar to how you have your basic Nginx deployment demo, you have your service description as well as your load balancer. And then once you deploy that, you can pretty much access that to the node of what you have, where you have basically given your Kubernetes deployment. So in my case, it's 130, and that's Nginx running there, right? I think that's given the time, I might just do that, and then let's cover the rest in the Q&A. I think
If you want to take 5 more minutes, Robin, go ahead and
no, it's just the direct deployment of that particular YAML file. It's just kubectl apply of that, so it should be fine. I think if we can spend a few more minutes on this highlight, some highlighted projects that that you can take away from this session if you're getting started. linuxserver.io is a very good website in to sort of see certain images or like even explore what you want to cover here. So if you just go to linuxserver.io, so they basically maintain a standardized set of images. So if you want to say Heimdall is one of the bookmarking, or let's say here. So they have a certain structure by which they maintain their applications in terms of configuration as well. So your time zone, etc. This is again basically targeted towards Docker, but you can very easily write a Kubernetes manifest for it. It's quite direct. You can get the templates as well. linuxserver.io, like that, is quite a good resource. PyKVM, if you have, in case you don't know what a KVM is, it's basically a way to sort of access your devices remotely, because servers not always have a display and a keyboard and a mouse, right? So a KVM essentially gives you remote access to that. So for your virtual machines, you have a virtual KVM, but in the case of your actual hardware, if you are away from it, so for example, this would be considered a KVM, right? But for your actual operating system, in case you want to enter your system's BIOS or something, that wouldn't be possible. So PyKVM is a good project for that. Reddit HomeLab has a lot of good resources. Tailscale is this peer-to-peer VPN solution that I mentioned if you want to access your services outside the network. And Home Assistant is the IoT solution that I mentioned. I think it might be good to pause for a Q&A here. In the interest of time, we can sort of either defer questions for later, or I can explain more in the context of any questions that you have. Okay, so just to answer Jojin's question first, the uptime monitoring service that I had, the graph generator is having some issue right now. But I think I will. You'll just have to take my word for it that it's up most of the time. How I handle this power supply situation of Bangalore is I'm lucky to be in a society that has generator backup. So power usually comes back within 1 minute to 5 minutes. So I have a UPS system that covers it most of the time. I had two ISPs, internet service providers, Airtel and ACT. So in case Airtel went down, ACT would take over. I had like a open vSwitch OVS solution to do an automatic follower, as in failover, sorry, to do that. So I'm using a consumer grade router right now from TP-Link. I want to change that to something like Omada or pfSense so that I have a bit more control over the networking. So in terms of uptime, that's how it is. Power supply is basically trusting the generator plus the UPS, and internet is using these failover connections. So Nilanjan has the question about the CNI for the cluster. Yeah, thanks. Even during the college days, what I dealt with was Raspberry Pi clusters. So we were like I had a funded project from the college for handling or rather making a K3s cluster from Raspberry Pis. And this is back when K3s was being managed by Rancher. So back then we did Kubernetes the hard way, deploying Flannel on that. In the HomeLab space, like I mentioned, my priorities are slightly different from Kubernetes development, so that's why I went with micro K8s. So I pretty much just depend on that to do that within, and have that as sort of a minor managed solution. You can have multi-node micro K8s clusters as well, so I think that should be fine there. The recording is posted. Recording is in progress. The link will be shared after the meetup. Mani, thank you. Thanks for the question. Anything else that I can answer?
Do you want to just touch upon K3s and micro K8s?
Yeah, sure. So I think the best way to this. So K3s essentially started off as a project from Rancher, and one second. K3s actually started off as a project from Rancher. It was later transferred to the CNCF, and I think it's an incubation stage, if I recall correctly. Their architecture is slightly different. The priority of K3s is to operate a bit better in resource constrained environments, and Rancher as a company itself is quite focused on compliance and industry standards and government compliance, etc. So depending on, so you also invest a bit of your time in the management of this as well. Micro K8s has better support in terms of like application level, from what I have observed. You can in most of these cases, as much as controversy there is about Micro K8s being from Canonical and Canonical's practices, it's you can flip a coin and choose, and then later when you come across some issue, you can consider whether or not you want to change. So Micro K8s is quite built into Ubuntu server, so you can very easily get started with it. That's primarily why I did it, and I'm not in a resource constraint environment, so that's primarily my decision here. The thing is, Linux community itself can be quite polarizing, right? Even if I say that I'm using Ubuntu server, there can be people ready to strangle me. So I'd say to each their own, and stick to what works for you. And yeah, whatever is faster, or whatever you can maintain, or whatever is sustainable for you would probably be the right choice for you. And it's a HomeLab. You can of course migrate and navigate. And right now, as I mentioned, I'm migrating between Portainer to micro K8s, right? So yeah, that's a brief overview of K3s and micro K8s.
You have a question from Kevin on the chat.
Oh, 1 second. Proxmox. Yeah, actually I do. So I have not. The question, for the interest of everyone, is with Proxmox, can you connect nodes or VMs in the cloud as well, having a hybrid kind of setup? So the way that you can architect that is in a couple of ways. Whether you can add Proxmox as like this data center, for example, if you have two more computers, you can add them in a high availability configuration. So your VMs will be sort of replicated, all of that. I am not sure. Maybe cloud services that offer bare metal services might allow you to run Proxmox natively. I don't think that would be directly possible. But I am all for hybrid setups. So, for example, I think fallback.thomasrob.in. So in case my internet connection is down, all of the DNS queries will get routed to this CNAME, fallback.thomasrob.in. That's actually a cloud VM that I have running on Linode. So in that way, I do tend to have some sort of hybrid services. Even the uptime measuring application actually relies on an SSH tunnel between my local machine, this Hudson server, as well as this cloud server. So you can have very very dynamic hybrid cloud setups. Even Kubernetes, if your master node is local, you can use Cloudflare tunnels, or even Tailscale has something called funnels to expose your application selectively. For example, out of everything that I showed you today, only thomasrob.in is the only thing that's available publicly. When we get started with home labs, or maybe even websites, we want to expose everything publicly. But the more that you start getting aware of the security, you get to know that that's definitely not the way to go. So I have pretty much locked down everything, and selectively using Cloudflare tunnels, or Tailscale has this thing called funnels. You can selectively expose TCP and UDP traffic outside. So that hybrid cloud solution depends on what exactly the application is you want to try to achieve. The cloud that I route to is Linode. They gave me a lot of free credits back when I was a student without expiry, so I have like still around $500 left. So most of my dev VMs are on there. I have no commitment towards Linode or Vultr, or AWS can get out of hand very easily. But yeah, it's your pick.
Awesome.
So one thing that I have not covered, like since I just touched, is the exposing of services publicly. I think Cloudflare tunnels and Tailscale funnels are my go-to recommendation. Port forwarding is the first answer that whenever you come across the exposing services solution, port forwarding is the answer you will find in most of the environments. This is what works for enterprise and works for people abroad. It does not work well in India, because our ISPs for maximum efficiency use something called carrier grade NAT, which you do not have control over. So I have lost a lot of hair because of port forwarding. I mean, the carrier grade NAT is not talked about as much. There is a separate proposal, or I mean, I've submitted that CFP, but either in next week's meetup, or there will be a separate YouTube video about exposing services publicly, about the security aspects as well as these port forwarding aspects, and CG-NAT. That's a separate topic in and of itself. So that's a different thing. I think, yeah, that no more questions. I think we can kind of wrap up there. Humble?
I don't see any other questions. I think we are good, Robin.
Thank you.
Yeah, thanks a lot, Robin, for a great session. It was really nice, and your experience with the HomeLab and the solutions around it. Yeah, it's really enlightening. Thanks for sharing your journey.